Ho, 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 Merry Hackmas. Thanks for joining us here on the Quirky Sage channel for day number 15 of the Advent of Cyber Challenge 2023. Try Hack Me. Today we're going to be talking about machine learning as we did yesterday. Yesterday was a little bit more theoretical. Today it looks like we're going to be doing machine learning a little bit more on the defensive blue teaming side. The title is Jingle Bell Spam. Machine learning saves the day. So jingle bell, jingle all the way. We're gonna jingle the machine learning today. Over the past few weeks, Best Festival Company employees have been receiving an excessive number of spam emails. These emails are trying to lure users into the trap of clicking links and providing credentials. Spam emails are somehow ending up in the mailing box. It looks like the spam detector in place since before the merger has been disabled, damaged deliberately. Suspicion is on McGreedy, of course, who is not happy with the merger. Ms. Skitty has been tasked with building a spam email detector using machine learning. She has been provided with the sample data set collected from different sources to train the machine learning model. All right. We're going to look at different steps in the generic machine learning pipeline, learn machine learning classification and training models, how to split data sets into training and testing data, how to prepare the machine learning model, and how to evaluate the model's effectiveness. I've already started the machine. Looks like we're going to use Jupyter Notebook like we did in day one, maybe day two. When we run the code, got to remember to hit shift enter, which if you've been following along, I had a couple hiccups with that last time. Machine learning. I want to keep saying learning. Machine learning pipeline. Uh, refers to the series of steps involving in building and deploying a machine learning model. These steps ensure the data flows efficiently from its raw form to predictions and insights. Typical pipeline would include collecting data from different forms, sources, pre-processing it, performing feature extraction from the data, splitting the data to testing and training data, and applying machine learning models to predictions. All right. Sounds like a mouthful. Ingest, clean, pre-process model deployment. 5 steps. Let's see. If I could make it to some type of an acronym, ICPMD. Okay. Importing required libraries. Before starting with data collection, we will import the required libraries. Jupyter Notebook comes with all the libraries we need for machine learning. Here are 2 imported key libraries, Nupi and Pandas, which these libraries were explained in the previous task. So is this word for word? I think this might be word for word to a point. And if that's so, I will get out the split screen and just go to one screen because ain't no point of seeing the same thing at 2 different screens. half the size, but you can see it full size. Yeah, that's what we're doing. All right. So Control Enter. Okay. So we imported it by hitting Control Enter. Data collection. It's the process of gathering raw data from various sources to be used. So we're using the pandas library to load in the data from the file. So we'll run that. Mm, Test check data. So this is head. If you follow for the few times I explained some Linux CLI commands, head prints the first 5 lines of the data that we got. So we got 0 through 4. So the first 5 lines. Um, so it looks like there's a classification of either ham or spam. Then the message. And some of these look like legit spam. Okay. Uh, so this takes the data and it puts it into a data frame. And then we're going to print what that data frame actually is. And it looks like it truncated the results. But we had the 2 columns classification and message, 4,451 rows, nice size data, depending on who you ask. Pre processing. So we're going to convert the raw data into clean, organized, understandable, and structured format suitable for machine learning. Given that raw data is often messy, inconsistent, and complete, pre-processing is an essential point. So this that goes for more than just machine learning. Making sure you have clean data supported for databases and building together like all types of operational things, especially um, garbage in, garbage out. I think I said garbage in and garbage out. Was it just an AI thing or a database thing in one of the previous lessons? It's not. You want to make sure you have all your information. You want to keep it structured. You want to keep it organized. You want to have it in a format that is readily accessible. And if you do have to convert it, you want to have it in a way where it's easy to convert without having to hire some type of programmer to write a program to convert data and have them waste 6 months on a project just converting data that you could have saved if you had your data sanitized and properly formatted to begin with. But that is that's not what the sermon is about today. So it is utilizing count vector. Okay. So on the last one, the data can't be in text, it has to be in a numerical format. So count vectorizer is going to extract the text and convert it into a number that can be used. So gonna run this. So we're gonna vectorize and transform the stuff in the message columns, because the message columns had text. Right. And now we're gonna print. So it's all numerical now. So now it's in a format for the database. It's important to test the model's performance on unseen data. All right. So we're going to split the data to train it. So testing is important. But the other thing is training supported too. But the dilemma is you can't overtrain these things, because then it gets to a point where if you overtrain it, then it becomes more like it's going to give you the answers it memorized, and it's going to perform more poorly on things that it's never seen. So we want to get it to a point where it recognizes the pattern, but it doesn't memorize answers, because then it's going to be more focused on recalling what answers were, and then when it realizes it doesn't have the answer, it's going to not be able to figure it out. So, um, we're going to run that. We're going to import the train test split, because we're splitting the data, and it looks like 20% of the data set is going to be used for testing. So that's what this point two is. And this is the classification. So now we dealt with the message. Now we're dealing with the classification too here. The Y is going to be the classification. And so we have X and Y training tests. Y is classification, and X was, I think we assigned X to the message. So X is message, Y is classification. 20% is, all right. We're going to run that. Okay, good. Naive Naive Bayes is a statistical method that uses the probability of certain words appearing in spam and non spam emails to determine whether a new email is spam or not. For instance, words like free, win, offer, and lottery might appear more in spam. The algorithm calculates the probability of an email being spam based on the words it contains. When the model is trained with nice Bayes, it gets a new email that says, win a free toy now. Then it thinks, win often appears in spam, so this increases the chance of being spam. Free is also common in spam, further increasing the spam probability. Toy might be neutral, often appearing in both. After considering all the words, it calculates the overall probability of the email being spam or in ham. So ham is a legitimate email, spam is a fake email, scam, social engineering attempt. If the calculated probability of spam is higher than that of ham, the algorithm classifies as spam. Otherwise, it's classified as ham. Let's use naive Bayes to train the model. So from this module, we reported multinomial MB CLF dot fit. All right. So that fit is the method used to train, which is funny. All right. So that's ran model evaluation. After training, it's essential to evaluate the model's performance on the test to gauge its predictive power. This will give you metrics such as accuracy, precision, and recall. All right. So classification report. Predict. Okay. So precision, recall, FL score, accuracy, about 96%. Okay. So precision is the ratio of correctly predicted positive observations to total predicted. Recall is the ratio of correctly predicted positive observations to all the actual positives. F1 is the harmonic mean of the precision and recall. It gives a better measure of the incorrectly classified cases than the accuracy metric when there's the imbalance between classes. A lot of this is statistical. We could get into the math more, but that's it. Testing. Once satisfied with the model's performance, we could use it to classify new messages and determine if they're spam or ham. So it looks like we're going to take this message here and transform it using the transform function in the vectorization object. And then we're going to take that and predict. And it should and predict. So it's going to take the X and pop out a Y. And we said that Y was classification and X was the message. So we're going to take that message and let's see if it tells it. Today's offer, claim your vouchers. Da, 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 da. I think it's spam. Yep. And machine learning or AI, if you prefer, thinks it's spam too. All right. So it says, good work. We completed one cycle of a machine learning pipeline, leaving behind deployment. Big Skitty has provided us with the latest email messages and asked us to test our model on these emails. Let's run our model in some tests and see if we can detect spam. Update the following code to include test email files and run the train model against these emails. So first we need to read the CSV. Um, so emails dataset.csv. Emails. All right. Print the head. Top 5. All right. Now you transform the messages and vectorize it into integers. So the message is vectorizer that transform. Transform a DF message. So it needs to be a data frame. This is a data frame. So we need to make a data frame. So we have our data frame. So we need to ship the, we need to change that to DF now. Oh gosh. Uh, test data. Test. Test underscore data. I think it's the same data. So data frame. I think there was other. other thing we did before we. We can stand threaded vectorizer, right? Vectorizer fit transform. What is it tripping on? Uh, this message. This message. That's what it was. New predictions. So it should give us the classifications. So this should print out the messages along with the got a key here message. This is it from the task. From the practical point of view, we have to consider the following points to ensure effectiveness of reliability of the model. Continuous monitor the model's performance on test data in a real world environment. Collect feedback from end users regarding false positives. Use this feedback to understand the model's weaknesses and areas for improvement. Deploy the model into production. All right. let's come back over here. This was all one for one. So what is the first step in the machine learning Python? Uh, Data sanitization. Oh, cleaning. Data normalization. Machine learning pipeline. So that was even further ingestion. Data ingestion. Ingestion. The key first step. Come on, scroll up. Ingestion, cleaning, normalization, standardization. Data pre-processing. That all falls under data pre-processing. Uh, really? I've been doing these challenges every day. Why? Uh, anyway, and used to create a new feature. So now we're looking at the data pre-processing, uh, feature extraction, no feature engineering, because we're creating a new feature. It says feature engineering. What's the percent weighted average of precision of spam? 0.98. How many test emails for more test spam? All right. I realized I made a mistake. My issue is we're looking at the wrong file here. So I I just reset it. This test emails.csv, not the emails data set. We have 35 emails. How many are marked as spam? One, two, three. So we have 3 emails marked as spam. And the emails marked as spam has a secret code. I'm not seeing the secret code. Prediction. Spam. Messages. Scroll down. It's a truncating of this. This. Still truncating off stuff. Not printing the whole message. Uh, why is it not? Mm, 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 mm. Let's try this. Okay. So 7, 5, and 0. It's not in 0. Try 5. There's our secret code. Mm, Copy and paste that in. And there we go. We have completed day number 14 of the Advent of Cyber 2023 challenge. Day number 15, correction. Day number 15. Thanks for tuning in. You have a great night. I'll catch you on the next challenge.